Here is a very good absolute maximum and minimum problem to discuss because there is a hidden critical numbers at a sharp point. So the hidden, I use a quotation mark because you have to do a little bit more work to find out. If you don't look at the graph, it is so easy to just miss that critical point. Okay, let's get started. So our function is f of x equals to x to the 2/3 times x squared minus 4 on a closed interval -1 to 2. The domain of this function is all real numbers. If you look at the first factor x to the 2/3, so the 3 in the denominator, that gives you a cube root, right? So that is equals to the cube root of x squared. So for the cube root, so the cube root of negative is defined, but the square root of negative is undefined. So that tells me, even though there is a radical sign, the domain of the entire function is still all real numbers. X can be positive, negative, or 0. So the domain is all real number. So let's find the derivative. For the derivative, do you want to use quotient? Do you want to use product rule? I don't think going for the product rule is a good path because you might have to do a lot of work when you find critical numbers. So this one, I will just distribute the x to the 2/3 and then not using product rule. You can use product rule, we will get to the same answer. So f prime of x, so maybe you should follow me first and then pause the video, use product rule, and then make sure you get to the same answer. And then, not derivative, we are going to do a distribution. So f of x, so that is x to the 2/3 plus 2, so that is 2 plus 6 equals to 8, so 8 over 3 minus 4, and then x to the 2/3. All right, and then we take the derivative. So this is 8 over 3, and then we have x to the 5 over 3 minus, bring the fraction down, then we have 8 over 3 as well, and then x to the -1/3, and then you set the whole thing equals to 0 to find a relative minimum and relative maximum, because a relative minimum can also, there is a chance that a relative minimum can be also the absolute minimum. So that's why we have to take care of the critical numbers. So for the critical numbers, we set that equals to 0. First, I would like to toss the second term to the other side. So we have 8 over 3, x to the 5 over 3 equals to 8 over 3, and then x to the -1/3, and then you can just multiply both sides by 3 over 8 to get rid of the coefficients. So now the coefficient is gone. You have x 5 over 3 equals to x to the -1/3, right? And then this one, you can raise both sides to the 3rd power. Raise both sides to the 3rd power, and then you multiply the exponents. You have x to the 5th equals to x to the -1, right? So equals to x to the -1, and then we can change the -1 to 1 divided by x, and then now we multiply both sides by x. So we multiply both sides by x, then we have x to the 6. We have x to the 6 equals to 1. So x to the 6, the 6 is a even number, right? So when you take the 6, when you do this, so you have x to the plus or minus the 6th root of 1. So therefore, you have x equals to plus or minus 1. So this is your critical number. Is that all? Do we have any other critical numbers? The answer is absolutely yes. Do you see that there is x to the -1/3? What I am going to do next is I am going to bring, okay, here. This is a good one. I'm going to take this out. I am going to bring this out. So that gives me x 8 over 3, x to the 5 over 3, and then minus 8, and then this is a 3, and then bring the -1/3 down to the denominator. So we have a cube root of x, so that is equals to 0, right? So when you find critical numbers, you set that equals to 0, you solve for x. And one other thing that you have to take care is you have to think about what kind of number makes the f prime fail. So you plug in a number to f prime, and then you are not going to get any slope. That is, do you see that the x is in the denominator? That is x equals to 0. So x equals to 0 makes the derivative fail. So f prime of 0 is undefined. If you look at the, but x equals to 0, this is not a vertical asymptote, right? So that means when x is equals to 0, there is a sharp point, as what you can see on the picture. So then x equals to 0 is also a critical number. That's why I picked this problem. So you have to look deeper and see, okay, so there is a x in the denominator, so we have to also pick out x equals to 0. So there are 3 critical numbers, 1, -1, and 0. So now let's do the testing. So let's do the testing in a different color. Let's do it in yellow. So we have plus or minus 1, 0, and there is a 2, right? Okay, so here is the testing. What's the smallest x value? The smallest x value is -1, and then we have 0, and then we have a 1, we have a 2, right? Okay. Oh, by the way, the reason that we have to point out the domain is you don't want to pick a number that will make the f of that number fails, right? So f of x, when x is equals to -1, so that gives you a -3. X equals to 0, that gives you a 0. X equals to 1, that gives you a -3. X equals to 2, we have a 0. So how do we do the evaluation? So our function is this, right? So f of 0, so that is equals to 0 to the 2/3, and then 0 squared minus 4, so that gives you a 0. So if you have a 1, f of 1, then you have 1 2/3, and then 1 squared minus 4, so that is equals to -3. Okay, where is the lowest y? So this is absolute min, right? So absolute min, and then absolute min, and then both zeros are the highest x, then they are absolute max, and then absolute max, right? So we have a 0, 0 for absolute, 2, 0 for absolute max, and then -1, -3, and then 1, -3 for absolute min. Let's check out the graph to make sure everything we did is right. Okay, I can do, okay, let's do the work right here. From -1 to 2, right? So from -1 to 2, let me switch to a different color. So how about this? So from -1, and then we go all the way to 2. So we go like this, sharp point, and then we stop at 2, right? So we have absolute minimum. So these two are the absolute minimum. So absolute min, -1 and 1. All right, I got it right. And then the absolute max. So 0, 0, and 2, 0. They are absolute max. So the graph just confirmed my answer. Okay, so that is the end of this video. Remember, when you are doing complicated derivatives like that, make sure to find out all the x values that makes the derivative fail. Okay, so that is the end of this video. If you think my instruction is helpful and clear, give me a like. Feel free to share this video in any social media for me. If you are new to the channel, spend 2 seconds to click the subscribe button down below. Thank you for your help. I will see you all in the next one. See you there.